Okay, so thanks everybody. My name is Katie. I'm the CEO of Thermexit. You can go to the next slide, please. So as electronics become smaller and more powerful, the risks of failure due to overheating will continue to increase. And today, 55% of all electronic failures are caused by electronics overheating. What we make is a thermal interface material that enables a natural but powerful transfer of heat away from the heat source. This allows thermal engineers to reduce size, weight, and complexity and cost of cooling mechanisms in electronics. In addition to enabling new technologies that can meet higher power requirements for applications that absolutely require high reliability and high stability, the end result is longer lifetime and better performance. Next slide, please. So we produce our thermal interface material gap filler pads. The way these work is they get sandwiched in between a heat generating component and a heat sink. What we have are two product lines, both with very high thermal conductivity, which is a measure of a material's ability to transfer heat, one of which is electrically insulating. So these are a non-silicone based, non-reactive, and no cure system. And our pads exceed competitor performance by 5 to 10 times in thermal conductivity. Next slide, please. So the key differentiator here is that these are not made with silicone. For high reliability applications, like anything, for example, in space, silicone is just not an option due to outgassing, which is really oil leaking from the pads that can short out critical components. A lot of times, the high thermal conductivity pads are based in silicone, so you have to sacrifice high thermal conductivity for reliability. Both of our product lines have passed NASA's outgassing requirements. Next slide, please. So both of our products were released this year. We've sampled out to about 75 customers. We're getting great feedback from them. We have a lot of applications where this could be a good fit, and it's a relatively easy design in most applications. But right now, our initial focus is in 3 specific areas. We're focusing on satellite payloads, also high power semiconductors, and embedded processors in aerospace and defense. Next on deck, we want to focus on 5G infrastructure and data centers. Next slide, thanks. So I want to talk a little bit about the thermal interface material total addressable market. So there's a super large market for thermal interface materials. It's about 3.4 billion by 2025. And that includes a wide array of thermal interface materials. So that's pads, pastes, greases. They come in a lot of forms. But pads themselves make up about 500 million of that 3.4 billion. With variants that we're working on in our product pipeline, we think a serviceable market could be around 40% or higher of this number of pads. Next slide, please. So like I mentioned, we have now 2 products that we're sampling out, and we have a bunch in the pipeline based on customer and distributor feedback. The first one we're working on is increased tackiness on one side. It seems like kind of low-hanging fruit, but it's actually super important for high volume manufacturing, because you don't want the pad to be slipping around as you're manufacturing. We also are working on softer pad variants. We're going to do that in Q4. And then working up to a larger sheet size. We're currently sampling in 5 by 5 centimeter squares. We're going to get our way up to 25 by 25 centimeter squares, and also thinner pad variants. We're working on scaling up production in the next 12 months as well. We're going to do that in 2 ways, by working with contract manufacturers and also by investing in equipment to scale up in-house as well. Next slide, please. So I just want to talk a little bit more about the team and the company. So my name's Katie, and we are currently a part of Nanoramic Laboratories. We are spinning out Thermexit into its own entity. We were accepted as one of 10 companies in the Techstars Space Accelerator program. That program started in June. We're about halfway through now. And we're working on accelerating the growth of the product line while spinning out into our own company and also seeking investment. The company, Nanoramic Labs, was founded back in 2009 by 2 PhDs from MIT. The initial core technology was this high temperature ultracapacitor. So we've always been focused in super harsh environment energy storage. Back in 2016, we pivoted and rebranded as Nanoramic Labs. Now the main focus of the company is on electrode material for lithium-ion batteries. And for a while, Thermexit was a side project. June Lee was our first employee that we hired. He's a PhD and an industry expert in polymer materials. He's our CTO. And on the team, we also have John Grillo, our Director of Business Development. So now Thermexit, in addition to the executive team here, has 6 full-time employees and a very different strategic profile than the rest of the company. So we feel like it's the right time now to spin it out into its own company, put a full management team behind it, put some fundraising behind it, and really accelerate the growth of the product line. I think I have one more. So, I mean, this is just a contact slide. We are raising money. If you want to talk more about that, please feel free to contact me. It's just katie@thermexit.com. And I guess it's a good time for questions.
Wonderful. We have a first question from Stan.
Hi, Stan.
Katie, thanks for your time. Nice briefing. Question for you, 2 questions. One, in the aerospace sector, granted the space environment is harsh, but the volume isn't high. But yet there are a lot of other applications that require, would seemingly benefit from your product, to include the unmanned world, where small environments, et cetera, require a lot of clever heat solutions. So why space? Why not something else with greater volume? And the second question, perhaps related, is are you still receiving government funding in any form of innovation research?
Thank you for those questions. Yep, I definitely agree that there are, wider applications for us to focus on. But the reason we want to focus on space is a couple of reasons. Number one is initially we want to get those, low volume, high margin markets to just get that beachhead. We also feel like once we can get qualified for space, there's a real high level of credibility there, because the standards for reliability in space are super high. So right now we're working with partner companies, Lockheed Martin, NASA JPL, and Israeli Aerospace Industries to get qualified for space. And we think that credibility is really going to carry us forward into some of those higher volume markets. Also, we're not ready to support the quantities needed by some of those higher volume applications just yet. So we're starting in the smaller markets, and we're going to expand as we grow. I think the second question was about government funding. So Thermexit doesn't currently have any government funds. Nanoramic was kicked off. They've had 2 really large grants from the DOE, a bunch of follow-on cash from NASA. They're also doing a program now with USABC. We have submitted for a few proposals for Thermexit, but we haven't heard back about those yet.
Good time.
Thanks, Dan.
Any additional questions for Katie?
I guess just a really quick one. How much capital are you planning to raise?
We're hoping to raise $5 million. We're a little bit further along than a true seed stage company at this point. We think 5 million will allow us to work on these current product variations, scale up manufacturing, grow up the team, and probably give us cash runway for about 18 months to 2 years.
And do you have an idea of how much more you'll need after that to be fully commercial?
I don't have a great idea of that right now. I would love to reconnect with you about that later as we kind of go through this process. But I will mention that, we never really want to be producing really large quantities. We're working now with a large manufacturer in the market. Our model is really going to be one of licensing. So we just want to prove ourselves in medium quantity applications and production, and then ultimately license it to one of these really large players who will add this technology to their portfolio of thermal materials. So we're not looking to scale up to be a huge manufacturing, company.
Hi, Katie. This is Diana Grauer from
Hi,
Technique
Diana.
FMC. Just a quick question. You're raising 5, gives you 18 months of runway. What team members are you missing right now that you need to hire and bring on board? You said you've got 6 full-time reports. What does the rest of the team look like?
Yeah, so there's 2 key hires that we need right now. One of them is a thermal applications engineer. What's been really interesting as we go through customer discovery is that, we can compare side by side the specs of our products, but when it comes for actual use case, the engineers use them in such different ways. It becomes very difficult for us to do a comparison. So that's one thing that we need right away, is somebody who can kind of understand the customer needs and then start running those experiments and comparisons. We also need a director of process manufacturing. These are the 2 people that we need right now. As we're scaling up to the larger sheet sizes and moving, our products from R&D to manufacturing, there's a lot of challenges that go with producing, manufacturing, and having, yields that are acceptable, and making sure we meet the spec every time and have a repeatable manufacturing process. So those are the critical hires now. I'll also say that, we plan on having some kind of service agreement with the parent company to start for certain functions that we're, using from them right now, that we will plan on scaling down over time. But initially, we'll use the service agreement with them and start to hire on our own people, for finance and HR and all those other functions that we'll be using the parent company with at first.
Go ahead, Ryan.
If we have time, so Ryan Hetcher from Lockheed Martin.
Oh, hi.
They're
They're a
happy to
partner
hear.
in the Techstars Space Accelerator.
Yes, ma'am. Yeah. So
Yeah.
happy to hear your interest in low volume, harsh environments, especially space. So one question I have is about the application space in particular. You mentioned that this material is roughly 5 to 10 times higher heat transfer connectivity than the competition.
That's right. Yeah.
Yeah. So a lot of times when I hear those kinds of improvements, it's often followed by an expansion of the application space. So obviously you're looking to, as a substitute and replace for existing products, but would this, at 5 to 10 times higher heat conductivity, are there other applications that you think you could get into, other markets you could maybe address?
Other markets we can address other than aerospace and defense, or
Other
like space
markets than just
applications?
a straight
Oh,
other markets than just a simple substitute and replace of an existing, instead of just displacing existing products. Do you think you could expand the market for this type of material?
yeah, that's interesting. I've actually heard a lot of feedback as we, have gone through a lot of mentor meetings, that if we could make this 3D printable, there would be huge markets for that. So that's something that would be great to add to the product pipeline. We also have been exploring thermoplastics as well, so using some of our proprietary methods in other ways. So yeah, I mean, the thermal pads is really just a start. There's a lot of technologies that are down the pipe in the pipeline that could use some of the basis of this to expand the market. Sure.